Hello and welcome to our video on the legendary mathematician Srinivasa Ramanujan. Was born in 1887 in a small village in South India and showed a remarkable aptitude for mathematics from a young age. Despite limited formal education, he taught himself advanced mathematics and made significant contributions to the field. Ramanujan's breakthrough came in 1913, when he sent a letter to the renowned mathematician Hardy at Cambridge University in England. The letter contained over 120 theorems, many of which were completely new and had never been seen before. Impressed by Ramanujan's work, Hardy arranged for him to come to Cambridge, where the two worked together for several years. During his time at Cambridge, Ramanujan made many groundbreaking discoveries. He developed new methods for solving mathematical problems, made important contributions to the theory of numbers, and even discovered previously unknown mathematical constants. One of his most famous contributions was the Ramanujan prime, a special class of extremely large prime numbers. He also developed the Ramanujan theta function, which has important applications in the study of elliptic functions and modular forms. Despite his many achievements, Ramanujan's health was poor and he passed away at the young age of 32. However, his contributions to mathematics have had a lasting impact and he is widely considered one of the greatest mathematicians of all time. Ramanujan's story is a testament to the power of self-education and the human capacity for greatness, despite seemingly insurmountable obstacles. Thank you for watching, and we hope you have a better understanding of the life and work of this remarkable scientist. Groundbreaking discoveries. 1. New method for calculating pi. Pi, also known as pi, is a mathematical constant that represents the ratio of a circle's circumference to its diameter. It's a very important number that is used in many areas of mathematics and science, including geometry, physics, and engineering. The most common way to calculate the value of pi is to measure the circumference and diameter of a circle and divide the circumference by the diameter. However, this method is not very practical for calculating pi to a high degree of accuracy. Ramanujan came up with a new method for calculating the value of pi that is based on an infinite series of fractions. This method is called the Ramanujan summation. In this method, Ramanujan used an infinite series of fractions to approximate the value of pi. The series is a sum of fractions where each fraction has a numerator and denominator. The numerator is a complex number and the denominator is the product of two integers. For a normal person, it's like trying to find the value of pi by breaking it down into a set of fractions. Each fraction has a top and bottom number, where the top number is more complex than the bottom number. When you add all the fractions together, it gives you an approximation of pi. This method is faster and more efficient than previous methods, and it can be used to calculate pi to a very high degree of accuracy. In simpler terms, Ramanujan found a new way of approximating the value of pi by adding up an infinite series of fractions. Each fraction has a numerator and denominator that are complex numbers, and the denominator is the product of two integers. This method is faster and more efficient than previous methods, and it can be used to calculate pi to a very high degree of accuracy. 2. The Ramanujan prime. A prime number is a number that can only be divided by 1 and itself. For example, 2, 3, 5, 7, 11 are prime numbers. Ramanujan discovered a special class of extremely large prime numbers, which are numbers that have unique properties. These numbers are so big that it's difficult to find them using traditional methods. They are called Ramanujan primes after his discovery, and it's a way of identifying certain large prime numbers that have unique properties. In simpler terms, Ramanujan discovered a special type of large prime numbers that have unique properties. These numbers are so big that it's difficult to find them using traditional methods, and they are now known as Ramanujan primes. It's like finding a needle in a haystack but with a specific set of properties that makes it unique. 3. The Ramanujan theta function. The Ramanujan theta function is a special mathematical function that was developed by Ramanujan. It has many important applications in the study of elliptic functions and modular forms. Elliptic functions are special mathematical functions that have many useful properties, and modular forms are a type of complex functions that are related to the study of symmetry in mathematics. In simpler terms, Ramanujan theta function is a mathematical tool that helps in understanding certain patterns and symmetry in mathematical structures, particularly in elliptic functions and modular forms. It's like a magnifying glass that helps in focusing on specific areas of math and reveal hidden patterns. The Ramanujan theta function can be thought of as a generalization of the Jacobi theta function, which has many important properties and applications in mathematics and physics. The Ramanujan theta function is defined in terms of an infinite series, and it has many interesting properties, such as modular transformation, which is a type of symmetry that relates different values of the function at different points. Ramanujan's work on theta functions has been influential in many areas of mathematics, including number theory and string theory. In number theory, theta functions are used to study the properties of integers and algebraic equations. In string theory, theta functions are used to study the properties of quantum mechanical systems with many degrees of freedom. One of the most interesting applications of the Ramanujan theta function is in the study of Mach modular forms, which are special types of complex functions that have many interesting properties. The Ramanujan theta function is closely related to the study of Mach modular forms, and it has been used to prove many important results in this area. In simple words, the Ramanujan theta function is a generalization of the Jacobi theta function, which helps in understanding the properties of integers, algebraic equations, and quantum mechanical systems. It has many important properties like modular transformation, which is a type of symmetry. It's used to study the properties of Mach modular forms and has been used to prove many important results in this area. For the Ramanujan conjecture, the Ramanujan conjecture is a statement about the distribution of prime numbers that was formulated by Ramanujan. It suggests that there is a certain pattern in the way prime numbers are distributed among the integers. In other words, it is a statement about the probability of finding prime numbers among the integers. However, it has not been proven yet, and it remains one of the most important open problems in number theory. In simpler terms, the Ramanujan conjecture is an unproven statement about the pattern of prime numbers distribution. It suggests that there is a certain probability of finding prime numbers among the integers. It's like trying to find a pattern in the way stars are distributed in the night sky. The conjecture is based on the idea that the prime numbers are distributed among the integers in a way that is related to the properties of modular forms. Specifically, the conjecture states that the number of prime numbers less than or equal to a given integer x is related to the value of a certain modular form at a point x. Despite much effort from many mathematicians, the conjecture remains unproven. However, it has led to many important advances in number theory, such as the development of new methods for counting the number of prime numbers and the discovery of new properties of modular forms. In summary, the Ramanujan conjecture is an unproven statement about the distribution of prime numbers that suggests there is a certain pattern in the way prime numbers are distributed among the integers. It states that this pattern is related to the properties of certain special mathematical functions called modular forms. It remains an open problem and has led to many important advances in number theory. I'll be explaining remaining discoveries in the next part of video.